Now? Ok. Bonjour tout le monde. Ça va aujourd'hui? Ça va, ça va. Awesome. Je m'appelle Joseph Marini. J'ai travaillé pour le Google. Don't worry, I'm going to do this in English. Mon français est très mal. So this is the session for Chrome apps, Chrome packaged apps for both desktop and mobile. I've only got about 45 minutes, so I'll try to get through as much as I can. So before today, who has heard of Chrome packaged apps? Most of you. Who's used Chrome packaged apps? We lost a few. Well, that's okay. Hopefully we can fix that. Actually, yeah, before I begin, let's just show some demos, because demos usually get people really a good understanding of what Chrome packaged apps are all about. So what I'm going to do here is use the Chrome launcher, just bring up a couple apps to show you what these are. Who's heard of 500 pixels? A few people? Okay, yeah, basically, if you haven't heard of these guys, they're a professional photo discovery service. So if you're a photographer and you want your photos to be discovered, you can upload them to this service. And you can see that I can scroll through these, right? Some really nice photos. I can click on photos and scroll through them, right? Nice performance, right? So, but the thing you notice is that there's no URL bar, right? There's no back button, right? There's no home button, no refresh button. But this is an HTML5 application. It's running on Chrome, right? It's using Chrome as the runtime, just like you would use Java or .NET as a runtime. So I launch it like any other application. It has, on the Mac anyway, it has its own menu bar. Right? On Windows, it doesn't. On Linux, it does whatever Linux does, that particular desktop environment. But if I didn't tell you this was an HTML5 application, right, you just wouldn't, the idea is that you wouldn't know. Another good example, here's a text editor called Carrot. And you know, this is a text editor like you've probably seen any other. But you know, we can open up some JavaScript code. You can see, again, right? No URLs, no back buttons, just a regular application, okay? So the idea is that you use Chrome like you would use any other runtime to build real applications. The user installs the application from the Chrome Web Store. They run across all popular platforms. They launch like any other app, and the user just has no idea that there's any difference. All right, so now that I've demonstrated what they are, let's head on back. Okay, so now the question, of course, becomes like, well, why would you do this? Right? Why would you build a native application out of HTML5? Why not just simply build a web app? Well, web apps are great. Don't get me wrong. Look, we're Google, right? We love the web. The web is awesome. There's lots of great web apps out there, right? There's a few of them right here. But there are times when the web just isn't really so great, right? There are times when web apps are not quite as awesome as they could be. To this very day, it's pretty difficult to make an app work offline reliably on the web, right? Especially, it's a lot harder anyway than it is a desktop app, simply because for desktop apps, native apps, you start from there, right? You start from offline, and then you add online capabilities. Whereas a web developer, you start online, and then you have to add offline capabilities. So it's two different ways of thinking of things. So that's one problem. Another problem, of course, is that you don't have all the great, rich input types that you normally have on the web, right? But like playing games are a great example, right? Games on the web are great. You get this full keyboard, accurate pointing device. But there are times when games just really aren't that great on the web, right? Wouldn't it be great if you could use real controllers and real USB devices and Bluetooth and all those great things that native app developers can use? That would be really awesome. So we built Chrome apps to help address some of these problems. First, they run offline by default. So just the way that you build a Chrome app, it's HTML5, it's JavaScript, it's CSS, but the way that you build it, it just runs offline just out of the box just because of the way you build it. We also built them to run across all of the popular platforms. So Mac, Windows, Linux, Chrome OS on desktop, and then iOS and Android on mobile. And I'll get to that a little bit later, right? So out of the box, 6 platforms. Chrome apps give you abilities that web apps don't have, right? Things like access to the platform, things like access to the hardware. These are things that the web just can't do natively, or is slowly beginning to be able to do, but it's kind of hard. As you saw before, right, rich, immersive user experience, right? The user has no idea they're using a browser, and distribution and auto-updating the same way you would expect any other app from any other store, right? Just like the benefits of the web give you like updating, Chrome apps update the same way. So every few hours, the Chrome runtime is asking the servers at Google, hey, is there a new version? Is there a new version? And then the server comes back and says, yes, there's a new version. So you upload your new version, it gets distributed out, everyone's happy. So I'll talk a little bit about each one of those in succession. So offline by default, what does that mean? What does offline mean? Well, there's two kinds of offline. There's no connection at all, right? You're on an airplane over the ocean somewhere, right? You're in the middle of the desert. There's no offline, which increasingly is not usually the case anymore. Most people are connected at least when they're stationary. There's the other kind of offline though, and that's just crappy offline, right? Or crappy online. For example, like you're in a cafe and you haven't bought anything in a while, and now the Wi-Fi is mysteriously not working. You're in a crowded conference, for example. You're in your parents' house and they have no idea what this Wi-Fi thing is. So that's the more common case of offline. But the thing is, native apps recover from this just by default of what they are, right? Because native apps don't have to ask the server for their UI. The UI is on the device. It's just the data that's coming down. So they're pretty good at recovering from this. You're using Sublime Text, you're using Eclipse. Eclipse doesn't just simply go white, right? There's no blank screen just because there's no Wi-Fi. So that's what Chrome apps help solve. So because of this, all your app resources are stored locally, and the user can launch the app anytime. You have to plan for how an offline experience is going to work. So for example, factor the app to have resources stored locally, right? So separate out your JavaScript from your HTML, from your CSS, abstract out the HTML layer from the data layer so that you're just talking data to and from the server the way that you would any other native app. Think a little bit about what your app's offline features are going to be. Not every app makes sense to have all its features available offline, right? Skype is a great example of this. Skype, 95% of Skype's value is only there when you have a connection, right? But when I'm offline, I should still be able to see my call history. I should still be able to manage my contacts. So there's still value in having it offline. You just need to think about this stuff. And so because we're running the Chrome platform, we give you a whole bunch of standard ways of working with this. So you can use the online property to see if you're connected or not. You can use IndexedDB. You can use the HTML5 file system. We also give you a way of storing data using certain Chrome APIs. One of the things that we do is we don't, in Chrome apps, there are certain web standard things you can't use, such as the Windows local storage, because it's synchronous. And so we take out synchronous APIs, we substitute them with asynchronous ones, because if you're storing megabytes of data, we don't want the user just sitting there waiting for your app. So we substitute things like that. We don't do, for example, synchronous XHR requests, right? So the way that you build a Chrome app, it's the way that you build any other web app. You've got your HTML, you've got your JavaScript, you've got whatever assets you're going to use, and you put all of those in your app, and then we just ask you to define two things. One of those is a manifest file. The manifest file just describes what the content of the app is, what its name is, what its version is, where the entry points are, that kind of stuff, just kind of similar to Android. And then there's a JavaScript file, and you can call it whatever you want. You can call it main. I've got it called main.js. You can call it whatever you want. But the point is, that's the file where the entry points into the app from the Chrome runtime are. So it listens for events like, hey, I was launched. Hey, I was updated. Right? I want to register different event handlers for the system. That's where that goes. So then you just wrap all of that up in a zip file, and then that goes up to the Chrome Web Store. On desktop, on mobile, it's the native app stores. It's Play, it's the Apple App Store. On desktop, it's the Chrome Web Store. And then that goes up to the store, the user installs it, and it's a single package, just like any other app. All right, let me give a couple of examples. So for example, storing data offline. So we don't use window local storage. We have a Chrome.storage API. This is the local version. There are other versions. But it works pretty much the way you would expect a storage API to work. You have an object here with key value pairs. Whoops. And then you just call Chrome local storage set. Because it's asynchronous, you have a callback function if you care. Right? If you want to listen to the result, you can listen to the result. If not, just go on your merry way. But there's APIs for storing data. You can also use the HTML5 file system. There's lots of ways to do this. All right, so let me talk a little bit about cross-platform. So I mentioned Chrome apps run across multiple platforms, right? Well, what does that mean? Well, if you think about what cross-platform used to mean, like this is years ago, before many of you were born, I'm assuming, but in the past, if you wanted to build a cross-platform app, you basically built an app for Windows, right, natively, the native apps. And then if you really cared about the 10% of people that didn't have Windows, you built a Mac app, right? This was cross-platform 15, 20 years ago. All right. Today, it's a little bit different. Today, you've still got Windows, but you've got multiple versions of Windows, right? You still have the Mac, but there's multiple versions of the Mac. You've got the mobile operating systems, right? Linux, and people use Linux. There's 20 million just Ubuntu users alone. And of course, Chrome OS, right? Chrome OS is getting more and more popular these days. So, I mean, this is crazy, right? Just on this slide alone, you've got C#, Java, right? You've got Objective-C, C++, right? Plus all the native APIs. And then there's all the hidden costs that developers don't think about, like building updaters, building installers, right? You don't want to waste your time doing any of that stuff, right? You want to have all that stuff taken care of for you. I used to work at Macromedia back before they got acquired by Adobe, and I worked in the Dreamweaver team. And I got tapped as being the installer guy. You don't ever want to be the installer guy. We will never leave you alone. Every installer question will always come your way. They look in the commit log and they're like, oh, Joe touched it last. Let's go ask Joe. So, okay, so that's cross-platform. So at the same time we want these things to work natively and offline, we also want to give users a great cloud experience, right? Because users expect that now. Users expect that when they have data and they store data in your app and then they go and use your app on their desktop from their phone or the tablet, that the data is just going to be there, right? This is stuff that you don't want to have to think about. You just want this to happen. So there are certain cloud-enabling features that Chrome apps just provide by default. One is, I talked about the storage API a few minutes ago for local. We also give you a cloud-based version of that. So do you ever notice how when you're using Chrome, who uses Chrome? Oh, just about everybody. That's awesome. Okay, great. Thanks. Thank you, everyone. Have you ever noticed when you're using Chrome and you're signed into Chrome that your bookmarks just appear on multiple machines, right? Just like magic. We give that infrastructure to you as developers as part of the Chrome platform. So with a few lines of code, you can sync data across all the instances of your app using the Chrome Storage Sync API for small data sets, right? The Chrome Storage Sync API is for like maybe several tens of K bookmark size stuff. But there is a much larger version called the sync file system. This is an HTML5 file system, but it's synchronized. It currently uses Drive as the back end, but it's open. So if any other developer, like Dropbox, for example, wanted to integrate into this, then they could. So if you want to store megabytes of data and have it synchronized across all your apps, this API does that. Again, just a few lines of code. We also have a push messaging API. And this is what's really great about the Chrome platform, is that when you think about how web apps work, right, your web app is only active when the user has the browser up and running and your app is in the tab, right? But when that tab is closed, the browser's not running, your app's not on the machine, it's not doing anything. Well, when you build a Chrome app, your app may not be running. In fact, Chrome may not even be running. But the Chrome runtime is always there, and it's always listening. So your servers can send a push message to your Chrome app. The Chrome runtime will wake your app up, run it, right, and say, hey, you got a message. Right? So as a web developer, you now have access to that kind of stuff. It's pretty cool. How many people love writing OAuth code? Yeah, I don't either. It's not fun. So we give you an identity API to manage identities. So for example, if you want to say, you want the user to log in for using whatever, you don't want to have to write your own identity authentication code. We give you that. There's two functions in there. One is for Google services. So if you want to just authenticate the user against Google because you want to use like the G+ API or whatever else, there's one API for that, and then there's one for third parties. So if you want to authenticate against Twitter, for example, or some other identity provider, we provide APIs for that. I see lots of photos being taken. I promise these slides will be available, right? Okay, so let me give you an example. So for the sync file system, One of the things that you can do is specify what the conflict resolution policy is. So, for example, here I've got last write wins. So if there's a conflict, then whoever got written last, that's the winner. I can specify it to be manual, and I can tell the system, hey, don't worry, I'll handle conflicts. It's up to you as the developer. So all you do is just call request file system, just like you would do any other HTML5 file system. And then you just start writing to the file system, and then the sync file system just takes care of synchronizing that data, right? Just goes up into the tubes, and it all gets synchronized. So for identity, here are those two APIs I was talking about. The first one is called getAuthToken. This is basically the Google Services version. And since the person using the Chrome apps, you have to be signed in to Chrome to use Chrome apps. That's just the way it works today. We're working on fixing that. But when the user's signed in, when you call this API, they'll get that little standard dialog that says, hey, this app wants to use whatever, your identity on G+, whatever it is. And the user says, yes, okay. They don't have to enter a password because they're already signed in. And off they go. They're off and running. For the third-party one, there's this API called Launch Web Auth Flow. And so in OAuth, right, there's this redirect that happens. Like you call the app says, okay, enter your password. Then it calls back to your back into your application with a token and stuff. It's all a big pain. So what we do here is, since there's no page or URL to redirect to, we just simply catch the redirect URL back from the service, and we pass it into your app here in the callback function, and then you just parse out the token, and you're just good to go. It's pretty simple. Okay, let's talk about user experience. Where am I? All right, I'm doing pretty good on time. Okay, so again, I showed this earlier. Chrome apps, they live outside the browser. They don't have to have URL bars. They don't have to have back buttons. They can have a user experience as much customized as you like. Of course, what this means is that your app is now responsible for things that it may not have been responsible for in the past. And users, of course, have different expectations of apps than they have of websites, right? They expect apps to behave a certain way, to be highly performant, to just, to behave as a native experience. They expect integration with the platform that it's running on. They expect things to just work differently. Users are just not in the frame of mind of working in a browser. We've taught users over the past 20 years that the web, you type an URL, right? It has to go get stuff, then it comes back, and then a little spinny arrow, right? Users don't like that in native apps, so they just don't expect that. So what does that mean? Well, we give you several APIs to manage the native experience. The first is a full windowing API. So for example, one of the most annoying things about native apps, maybe you've seen this, is you get the app just the way that you want it, right? You get you move the window where you want it, you size the window where you want it. How irritating would it be if you quit the app and then you came back in and the window's this big, right? Those are the kinds of things that users hate. But as a web developer in the past, you had no control over that, right? The browser would say, here is your window size. And your app would say, okay, that's my window size. But now you're responsible for that, right? You're responsible for sizing the window. So you can do things like get the screen size to determine where your window should be, how big it should be. Remember where it was, right? Because you don't want to irritate the user. You can control whether the title bar is shown or not for your app on the particular platform. If you don't like the way the title bar looks on a platform, then don't use it. You saw the 500 pixel example. They were using the Mac system title bar, but the Caret, the text editor, was not. Right? They had their own title bar going on. You can do the same thing. All you do is there's a CSS property called WebKit App Region. You set it to drag. You put that CSS property on whatever you want the drag region to be, and it can be more than one thing. And then that's it. Now it's a draggable region now. We have a context menus API. Users have this really irritating thing, right? They right click and then they expect something to happen. So we give you an API to help make those things happen. Because again, context menus in the web, bit of a pain. The cool thing about this API is that it works outside the app. So for example, when you specify a context menu using this API, if somebody right clicks on your app's icon in the launcher, it'll work there as well. You can specify that it works there. So nice little platform integration feature for the user. There's an alarms API, so you can set an alarm to be called in the future. And again, this works whether your app is running or not. So you set an alarm in your app goes away, the alarm still fires, the runtime tells your app, hey, an event happened. So there are APIs for accessing the media galleries on the user's device. So for example, getting access to photos, movies, music, right? Again, all of this stuff is behind permissions, obviously. When you install your app, the Chrome Web Store says, hey, here's what the app wants to do, and you have to say yes or no. But, so all of this is secure. There's also a URL handler API. This is pretty cool. So your Chrome app can say, suppose like you have a document editor, and somebody gets an email with a URL to your kind of document. Your app can tell the system, hey, I handle that. Right? Now you have to own the URL. You can't just simply say, oh yes, I handle Gmail URLs. No, you can't do that. You have to prove ownership of the URL for your app to do this. But the nice thing is that when someone gets an email with a URL that you own in it, and you've registered the handler, your app can launch in its place and say, I know what to do with this data. All right, let's talk a little bit about integration with the OS platform. So one of the nice things about Chrome apps is they have access to the underlying hardware. So for example, they have access to the networking layer. They have access to the Bluetooth controller. They have access to the USB ports. So if you're building an app that you want to be able to work with external hardware or the platform, then this is pretty straightforward. Again, it's a cross-platform API. So if you want to work with USB devices across multiple platforms, there's an API for doing that. Now, obviously, once you get access to things like the platform, certain things become pretty important, such as privacy and security. I'm sure being here in the EU, you guys are all about privacy and security, right? I go to every website here, it's like, do you want cookies? I'm like, yes, I want cookies, God. So, man, this is why engineers should never be allowed to name marketing things, right? Because if the Netscape developer who developed that feature had just simply called them what they are, like user document settings or whatever, everything would be fine. But no, because they called it the magic document cookie, oh my God, what are cookies? So anyway, this stuff becomes really important when you're accessing the hardware. So just be clear to the user when you're doing this stuff, right? This is important. Now, in some cases, you have no choice. Right? You want to access the camera, that little light comes on, right? The hardware just does that. But in some other cases, like you're writing to the file system or whatever, it helps to be clear to the user that you're using these resources because, again, they should feel like they're in control. And again, when you're consuming these resources, you have to be careful because as a web developer, you didn't have to care about this stuff. But when you're using things like the microphone and the camera and the USB port, right, there are power implications on a laptop or a tablet. Right? There are all kinds there's sharing issues, like if you've got, the file open and somebody else wants the file open, they can't have it. So there are things you need to think about when you're doing this stuff. But anyway, the APIs are there for doing deeper system integration. Who knows what content security policy is? CSP, a few people. Okay, wow, I'm about to introduce you to a really fun subject. So content security policy is it's a new standard, relatively new standard that has a direct impact. It's not just for apps, by the way. It's a web thing. But Chrome apps implement what's called the content security policy. So rather than go deeply into what it is, I've provided a link here so you can read about it. But there are some implications for what happens when you're working under CSP. First, there are certain things you can't do. So you can't use the eval function in Chrome app code. Eval is a big source of potential security hacks and bugs and so on. So there's no inline execution of code. You can't use the new function constructor inside Chrome app code. Now, there are ways around this, so don't panic. People are looking at me like, wait a minute, what? So no, there are ways to get around this stuff. But so things like, no, you can't use new function. And by the way, the eval, that also means things like in set timeout, for example, you can't pass strings of code, right? You have to pass an actual function to set timeout, things like that. All JavaScript code has to be in separate external JS files. You can't have inline script blocks in your HTML. Because we have no idea how it got there, right? If somebody gets control of that web page and puts that script tag there, we don't know where that came from. However, in your manifest file, when you declare a JavaScript file, okay, we know that it's part of your app, so we have a reasonable expectation that it's safer than just allowing arbitrary code to execute. Similar to the above, there's no inline event handlers. It's a bad practice anyway. But you can't do things like body, onload equals whatever, right? You have to use add event listener, that kind of stuff. Again, just some of the stuff is stylistic, but it's important to know about. When you want to use things like iframes, iframes in Chrome apps get sandboxed into their own origin so that the code inside the iframe can't poke out to the host window and execute code in there. And same thing with you. You can't just go into the iframe and just start randomly executing code. You can use message passing. So the iframe, for example, can pass a message to its parent window, and then your app can execute the code based on the message. Similarly, your code can post a message into the iframe. So you can still communicate back and forth. You simply can't call code in their respective origins. And you need to declare where the content comes from if it's not local. One of the things about Chrome apps is that media types, except for video and audio, have to be from the local machine. So you can't just simply say image source equals random path on web. That image has to be downloaded locally and then displayed in the window. So the way 500 Pixels was doing that, for example, was they fetch the resource using using Ajax. I hate saying XHR. They're using Ajax. They fetch the data, they bring it down locally, and then they have an object URL which refers to the local object. Now, this obviously in Chrome apps, this scenario is going to come up a lot. So we built a utility JavaScript library that's on our GitHub for you to use if you want to do this, and I'll show that in a little bit. Am I doing okay? I'm doing good. All right, but then of course the question becomes, wait, I want to do all that stuff. I want to use new function. I want to use eval. There are ways to do this. So if you want to embed rich web content in your app, we give you a browser control called the web view tag, which is basically like embedding Chrome with inside Chrome, right? It's a little bit Inception-like at that point, but it actually works pretty well. Now, it's not the full browser. You can't embed Chrome with all of its extensions, right, and plugins. It's just the web rendering engine inside your app. So if you have rich content like, I don't know, whatever, documents, help content, whatever it is, you can embed a viewer inside your app. And you have access to all kinds of events, like when the page loads, when script wants to run, that kind of stuff. For accessing remote resources, I just described this. You fetch it with XHR, then use a blob URL. We give you a library for that. One of the most common issues that will come up is when you want to use like a templating library, for example. Like some templating libraries, they just use eval or whatever to compile the template into a function. So there's a couple of things that you can do here. First is, well, you can use a library that pre-compiles templates. Handlebars, for example, does this. But another option is that you can use what's called a sandboxed page. Your Chrome app can tell the runtime that I have a web page that's sandboxed into a separate area, and that sandbox page is allowed to do all the things I told you not to do on the previous slide, right? You can use eval, you can use new function, you can use all the things you want to use, and then you have to pass messages back and forth. So that sandbox page can't just execute code in your app and vice versa. So that way things are kept nice and separate and firewalled and safe. All right, let me talk a little bit about mobile. How many people know what Cordova is? Apache Cordova? Okay, most everybody. When Adobe bought PhoneGap, they open sourced the framework and they called it Cordova. And so we have a team of people working on Cordova. Actually, I think we were probably one of the bigger contributors to Cordova now. We have about half dozen engineers just focused on that. So what we're doing is we're bringing key Chrome app APIs over to the iOS and Android platform. So for example, the identity stuff I talked about before, the storage and syncing framework, like the kinds of things, the kinds of services you'd want to be able to have in a mobile app. Payments, we'll see if Apple lets us do that. So they now because it's Cordova, the way that this works is it executes within the host, whatever the host web view control of the operating system is. Now on Android, right, starting with 4, that's Chrome. On iOS, it's the UI web control. So it's not quite Chrome on every platform there, but it's based on WebKit, so it's similar. The workflow is pretty straightforward. You basically install the mobile toolset. like Eclipse or Xcode, whatever it is, you can start from scratch, or you can take an existing Chrome app and import it and work on it, work on the mobile version. And then you just iterate over your HTML and JavaScript code just like you would on any other mobile web app. You can use the Chrome developer tools for debugging. So you can attach to the remote process on the device and debug like you would normally, which is really, really nice. And then you distribute these via whatever the native app store is, Google Play, right, Apple App Store. And then in the future, we'll look at other platforms as they warrant. But right now, those are the two. So currently, we've focused on a set of Chrome apps APIs that we're initially going to support. So these are the, I think, 7 or so that we're looking at. And we've actually made pretty good progress. So on Android, these are all supported. I think notifications actually might be there on iOS now. So this might be a little bit out of date. But payments is kind of a weird issue. We'll see if we can actually bring that over or not. But we've made some pretty good progress on this. So we launched a developer preview of this in, I think, back in February or January somewhere. Yeah, I think it was like the end of January. So if you want to download, it's on our GitHub. You simply go to github.com/mobile Chrome apps. I'll show the URL. But just go there. You can download the tool set and get what you need. So let me actually just bring that up in the browser so you can see. If we go to, let me bump this up so you can see this stuff. So this is our GitHub repository. We have all the stuff that we do is open source. It's all in the Chromium build. So all of the Chrome app runtime things that we're building, we're upstreaming back into Chromium as we do this. So if you want to see how it's built or get your own fork, wow. Okay, yeah, you can. Maybe I'll just stand perfectly still. That's what I'll do. All right. Maybe it's that. Okay, there we go. So yeah, so Google Chrome/Chrome app samples. In a couple of minutes, I'll actually walk through a couple of these. The other one that I wanted to show was github.com/mobile Chrome apps. So this is our repository for the mobile stuff. The one that you're going to be interested in is this one right here, mobile Chrome apps. The rest is all just support stuff. So this is the one that you want to check out. So to learn more about this stuff, before I show just a few coding demos, let me just bump this up so you can see this. This is developer.chrome.com/apps. These URLs are in the slides at the end of the deck, so don't worry about writing this down. But the idea here is that this documents all of the different APIs. If I go to the platform section and I come over here to Chrome platform APIs, this should give you an idea of just how many APIs there are available in the system. So a couple of these I talked about, like alarms, for example, but it's a pretty long list, right? So these are all the kinds of things that you can do in Chrome apps. So let's see, yeah, it's a pretty good list. So having shown that, let's just take a walk through a few examples. And to do that, what I'm going to do is bring up my Chrome Apps Developer tool. If you install the Chrome Apps SDK, actually this is built into Chrome now, and you may recognize this. This is, if you've ever seen the Chrome extensions page in the browser, that's what this is. But this is actually itself a Chrome packaged app. So we factored that out, made a packaged app out of it. We made the UI a little bit nicer, so now we separate apps from extensions, for example. But you can do all the same things in here that you would do normally. So let me just show a simple example. Let me bring up that text editor, because it's fun just to work in a native app. So let's go ahead and open up some code. I'm going to open up a file. I'm going to go to my documents, and I'm going to open up in my Chrome Git. This is the Hello World example. So I'm going to open up the manifest file first. So this is what a typical can you guys see the code okay? Should I make, you guys in the back, should I make it a little bit larger, or are you okay? You okay? Yeah? All right, good. So this is what a typical manifest file looks like. And this one's really simple because the Hello World app doesn't ask for any permissions or anything like that. All it does is launch, build a window, and then show a Hello World message, and that's it. So you define things like what the name of your app is, what its version is. Now that's different from the manifest version. This is for the runtime. This is your apps version. And you can use whatever versioning scheme you want, right? 2, digit, dot digit. You can use 4 digits. Doesn't really matter. You can specify if there's a minimum Chrome version that you need to run on. So, for example, if there are APIs in newer versions of Chrome and you want to prevent the user in the Chrome Web Store from installing the app when it won't work, that's how you do it. You provide us some assets like icons, and then you simply tell the Chrome runtime where your entry point is. So in this case, I'm just saying, hey, main.js is where my entry points are. So let's open that up. And that's this file right here. All right, so what's happening is, in the runtime, I'm listening for the onLaunched event. And this is a asynchronous function, so I get a callback. And then inside the callback, I'm going to create a new window and center it on the screen, right? So I ask the screen what its available width and height is, and then I have a width and height for the window. And then I use the windowing API that I talked about earlier to create a new window. And if you give your window an ID, then we'll do things for you, like we'll remember what the last position was, what the size was, so that takes that off of your shoulders, right? So we'll do things like that. So that's basically all this does. So if I save this, and back in my tool here, I'm going to load this to test it. Now, to do this, to load this and test it, it's just like any other extension you may have built in the past for Chrome. I'm just going to go over to the folder, scroll down to the folder of code, select it, right, and it installs there, and I can launch this, et voila, right? So it creates the window, right, there's hello world. What's cool about this is because this is Chrome, under the hood, you can do things like use all the debugging tools that you're used to using in Chrome. So if I inspect this element, I get the regular Chrome debugging tools. This is all the stuff that you have access to inside of regular Chrome debugging. So as these tools get better for regular web developers, they'll get better for app developers at the same exact time, because it's just Chrome, right? It's all just Chrome. So let me close this. Let me show you a little more advanced example. Yeah, I've got time. So let me load another example. Let's go down. I talked about identity. Let's show identity. Okay, so I'll load that up. And actually, before I run it, let me show you what the code looks like. So we'll go to the identity example, and that's this guy here. So we'll bring up the manifest first. Now, in this case, there's a couple of different things going on. First, you notice there's a permissions line, right? The permissions line says, I want to use things like identity. I want to be able to access things like accounts on the Google domain, right? I want to be able to call Google APIs, right? So I'm specifying inside the permissions not just the keyword that says what I want to do, but what URLs I want to be able to access as well. And then here's the OAuth 2 stuff, right? You get this stuff from the Google developer dashboard or whatever dashboard you're using, just like any other app. So I have my client ID, I've got the scopes that I want to access. And then in the code itself, that's going to be, let's see. So in the main file, again, just creating a window. And then the magic all happens in here. So what we're going to do is right here call the getAuth token function, right? So this is the function that just says, hey, go ask the user if it's okay if this app runs. And if they say okay, then great. If they say no, then, well, whatever, right? Just don't do anything. And then you just access the APIs on the web using XHR like you normally would, right? So now that we've loaded this, let's go back here, and I'm going to launch this. All right. So what I'm going to do is click the sign in button, and it's going to get the token, right? So now notice I don't have to enter a password, right? Because I'm already signed in to Chrome with my identity. I'm going to say just for me, and I'll accept, right? Say, yep, sure, everything's fine. And so it's going to go off, and you can see now it's got the token right there. Sorry that the font is small, I know, but so it came back with the token, and now I can do things like get my personal data, right? So there's my photo, there's my name, right? This is my G+ identity. So I'm calling it G+ API to get this stuff, and then I can revoke the token, and when I revoke the token, the data goes away, right? So again, pretty straightforward using identity. Let's look at something a little more advanced, and I'll try to leave some time for questions. So last example, Let's just close these guys, and let's go to the browser sample. So what I'm going to do here, this sample asks to use the web view permission. So what I'm going to do is embed the Chrome browser inside my app, right? So I'll just open up the source code that shows you where we do this. And that guy is here. So right here on line 23, that's where the web view is. It has a default source, and it has a default size. And what I'm going to do is load this and run it. So let's reload the browser, select that folder, and we'll launch. And you can see that I've basically built a browser out of a Chrome app, right? So I guess I might as well just ship this. But you know, we can go to two things like let's go to let's go to Devox, the Devox site, right? Right there we are. Now I have a little button here that simulates a crash because you know Chrome just never crashes, right? So I'm. You guys laughed a little too soon on that one. So I guess you know there's an API that provides a handler for exceptions. You can handle crashes gracefully. That's what I'm doing here. So anyway, it looks like I've got about 10 minutes left. So let me just before we finish up, let me go back here. Let me put up this slide to remind you of what the various URLs are. So that's pretty much all I have. So thank you for your time, and I will take questions. All right. Anybody have any questions I can answer? I'll repeat it. Go ahead and just put your hand up if you have any. All right. And while you guys are thinking of questions, let me just prove to my boss that I was here, because they want to make sure that I was actually here. All right. Very good. Thank you. Yeah. Question over here. Sure. Oh, we have a mic. Yes. Excellent. Yes.
Hello?
Yeah.
Is there any 3D handling?
WebGL.
WebGL.
Yeah, because it's Chrome, you can use web technologies that are in Chrome. So, yeah. Other questions? Yeah, sure.
Yeah.
Yep, sure.
You said the Chrome app support in iOS.
Yes.
So how the user can get the Chrome app on iOS?
Yeah, so what you do is as a developer, when you build your Chrome app, you upload it to the Apple App Store, and then it's just like any other app in the App Store. Well, yeah, no, it's built using Cordova, right? But what happens? So Cordova is basically a native app shell around your web code. So the Cordova team builds like a native iOS shell and a native Android shell, and that just hosts your code. Okay. And so you upload it as you would any native app.
So you have to upload it with the Cordova together.
So what happens is, so Cordova is basically like a library. Think of it as a library you link against. It's not something that you have to upload to the Apple App Store separately. It's like, it becomes part of your app.
Okay.
Yeah.
Anybody? No?
Other questions?
If you see
right here. Yep.
Okay.
Do you provide threading APIs, or do you have to use web workers or something like that?
I'm sorry, APIs for WebGL, 3D?
No, for threading.
Oh, for threading. Yeah, so because it's Chrome, we do support web workers. Yeah, so you can use web workers, WebSockets, yeah. Basically, if the underlying Chrome runtime supports it, it'll work in the apps. Yeah. Other questions? Yeah, sure.
What's the difference between a web view and an iframe?
What's the difference between the web view? So Chrome, you have to remember, Chrome is a full browser, right? It has a UI, it has support for plugins, extensions, right? It has a way for handling downloads, right? So it's all the stuff that has nothing to do with rendering the page. So the web view just renders the page, whereas Chrome is this app that does all these browsery things, handles bookmarks, right? Handles, you know. So back in my sample browser app, if I wanted to handle bookmarks, I'd have to build that, right? I'd have to build a bookmark handler, set the URL, tell the web view to go there, all the things that the browser app is doing for you.
Yeah.
Yeah.
So we can access USB, but is there some higher level libraries to access USB hardware? For example, NFC or?
Yeah, so there's a USB API. So let me just go back to this page and do a search on USB. So this is the USB API. So this is pretty much the API. So you can like look for devices, right? If you have the device ID, you can request a device ID. So it is you don't have to send bytes directly down the wire. You can actually call a higher level API. Yeah. Yep. Another question up here? Yeah.
So two questions.
Yeah.
Can I use AngularJS?
Yes, Angular, yes.
And
it'd be pretty embarrassing if we couldn't use Angular in Chrome apps. Yeah.
And what is how the application is updated?
Yeah. So when you upload the app to the Chrome web store, so the native app stores like iOS and the Play Store have their own update procedure, right? So when you upload a new Play app, right, the Play handles the updates the way Android does it, because it's an Android app at that point, right? In the Chrome Web Store, whenever the Chrome runtime is running, when you've got your machine on, right, the Chrome runtime about every like 5-ish hours or so pings the Google servers and says, are there any updates, right? And then the Google servers come back because it knows what apps you have installed. So if you upload a new app and you increment the manifest version number in your manifest, the web store sees that and then tells the runtime, yes, there's a new version of this compared to what you have. And so then the new version gets downloaded behind the scenes. And there's also a way for your app, however, to force an update. There's an API to say, hey, is there a new version? So that way when your app launches, you don't have to wait for the server to come around. You can just simply say, check for updates, and then you can show the user a little dialogue that says, hey, should I update this now? Carrot does that, for example. Yeah, so there's ways to do that. You can do it manually or wait for the server. Yep, right over here. And then up here after that. Okay. Yeah.
Cordova has its own API, so how do you incorporate the Chrome API into
Yeah,
Cordova?
what we're doing in the case of Cordova is we're building, so in the case of Cordova, it's basically plugins. So we're taking the Chrome APIs and we're building Cordova plugins that implement the Chrome APIs. So it's kind of an API on top of their API, right?
Ah, okay.
Yeah. And then up here, yeah.
Hi, I just want to ask about deployment. So
Yeah.
we basically deploy to the Chrome store, and then it's available on desktops, right?
Yes, right.
And for mobile, so we have to upload it as a native app to the store, specific store.
Yeah, right.
So for iOS, we have to upload to the App Store.
Yes, right.
And on Android, it's not. It's also the same thing. It's available
Google
as a
Play.
native app.
Yeah, Google Play, right.
Okay, so we have to do two things to have it available on cross OS.
Including desktop, 3 things, right?
Yeah.
Yeah.
All right. Okay. Thank you.
Yep. Yeah, the Chrome Web Store, just to be clear, so there's a couple ways you can publish in the Chrome Web Store. You can publish so the whole world can see it, or you can publish it so only people who have your link can see it. And then if your users have a Chrome apps domain, like a business apps domain, then you can set it up so only people in that domain can see the app, right? So we get this request from enterprises, for example. They don't want the world to see their payroll app, for example. So there are ways to just manage who can see your apps. Yeah.
So
Yeah.
it was just answered. You can have a private
Yes.
app store.
Well, it's not quite your own private app store. It's just a view into our app store that only your domain can see. Yeah. So you don't host a version of our store on your server. Right. If you really wanted to, you could go get the Chrome Web Store source code, get Chromium, right? Build your own thing, but I don't suggest that. As you could also sew your own clothes, right? I mean, why would you do that? So, yeah. All right, I think that's all the time I have. So I'll be at the booth. If you have any other questions, please come see me. Thanks, guys.